So, okay. So what we are going to do today is that we will try to cover all the lessons that we have, okay, about data management. Okay. Plus, for this lesson, no, I will not tackle any computations. Okay, I will not tackle any computations because you are done with this. So, dili na ako balik-balikon. So, ang kwan lang nako ani is that um, the interpretations, dayon, uh, when to use this kind of measure, no? So we will try to discuss it one by one. So it's kind of long, pero I'll try to summarize it in maybe in 1 hour and 30 minutes. So I hope you bear with me. Okay. Sige, I will just start, no, with maybe I will just start. So this is just a review on the descriptive and inferential statistics, no? Okay, so we will start with the descriptive statistics. Okay, so tanan, you know? So we have what we have seen there, like summary statistics with the plots, no? So na ay mga mean, standard deviations, and so on. Then you have some graphs. So from the raw data, then you try to summarize it, no? So that it would portray something. So that is the use of descriptive statistics, no? So all of these are descriptive statistics. So murag nakakita man siguro, murag nagagamit man siguro ninyo nino. Murag maklaro ra sa inyong sa tawagan na. Murag I see mostly of you apply this one regardless of any type of data that you have. So na with regardless if it's categorical or numerical, so na na siya corresponding descriptive statistics. Okay? So yun, so that's how that's the one of the purpose from raw data, parang you try to make it more organized and present it in a meaningful way. So descriptive statistics is just gives us information or helps us describe the characteristic of a specific data by giving short summaries about the sample and measures of data. So gikan sa raw data, imo gi-summarize and present it in a meaningful way, no? So na ay tabular approach, na ay maapoy graphical approach, okay? So yon. So descriptive statistics covers the following, and I guess you have used this one in your paper. Either one of this is being used in your paper, no? So yon, so that covers all about descriptive statistics. Then, okay, so we also have the frequency and percentage distributions. Okay, so what is the use of this one? Okay, so I will not be tackling how to create, no, how to construct frequency distributions. So anyway, you already have this one. All you have to do is to count, then summarize, no? Then pwede na gani si Excel will do it for you. Okay. So this is used when we measure how often something occurs. Ano? Okay, this can be done by frequency or percentage. So that is the purpose why we do frequency and percentage distributions. Especially if you deal with categorical type of data, no? Mga categorical type of data, so pwede na to i-present using frequency and percentage distributions. So Okay, this tool can be represented by the following. It can be presented by the table. You have that one. You can also present it through bar graphs. You can also present it in pie charts. Okay, class, about pie charts, no? Use pie charts if you have at least 4 categories. But beyond that, dili na applicable ang pie charts. Gubot man gud na siya tanawon. So kung nana kay 5 or 6, tabular na lang or pwede i-bar graph nimo, no? For okay ra nang pie chart if na kay 3 or 4, 2, 3, 4 ka category just like what of this one. Pero kung 5 na, pangit na siya tanawon. Then we can also present it through line graphs. Then if you have katong mga intervals, no, katong mga raw data imong gi-transform into intervals dayon nagbuhat og frequency distribution table, then you can present it through histogram, frequency polygon, and ogive. Okay? So, yun. I will not discuss this anymore, no? Anyway, you have that one in your statistics one. So, yun. So, we present it when we are going to deal with, when we try to measure how often something occurs, especially if our data is categorical. No? So, that's the purpose why we use frequency distributions. So, parang namin nagamit siguro frequency distribution sa inyo. Para ba? Okay, so we also have measures of central tendency. So, basta measures of central tendency, naagna sa tulo, mean, median, and mode. So, pag may tag central tendency, so ginapangita niya ang center or average of the given data. What we know about average is ang mean. Diba? Pag may tag average, mean magina siya. But actually, in statistics, there are 3 measures of average, na ay mode, na ay median, na ay mean. So, ang mean mo ng common yung average, di ba? Ang median is katong middle value, kung atong nga. Ang mode yon is the most frequent. Okay? So, kung categorical ka, you want to look for mode, so dadto na lang dayon kamutan sa imong frequency distributions, no? Okay, so okay, when do we use mean, median, and mode? Okay. So, I can summarize them through this table. Okay. So, we use mean if the data are in interval or ratio scale. So, therefore, it is in numerical by nature. And also, ang iyang distribution is approximately normal. Unsa din ang normal nga distribution? Kana bitang gitawag nimo nga symmetric nga distribution. So pag may symmetric ang distribution, ang pinakadaghan o ang tunga-tunga o ang average naglay sa the same location. Kung dili man gani kuan, kana almost equal, okay lang. Sige, I have this recorded naman. Okay. So, yun. So, we use mean if the situation is like that, no? So, symmetric siya ang imong distribution. No? Namo kay uban data, mag-collect ka og data, especially kanang mga experimental na type of data or kanang mga gamay ra imong data. Namo kay uban nga nag-exist og outlier. So, ang imong kuanana, ang imong pormaana skewed, hiwi. So, wala. Ang location sa imong pinakadaghan, tunga-tunga o ang imong average, naglahi-lahi. So, in that case, skewed na siya, no? So, for that case, we will not use the mean. Okay, we are not going to use the mean. But instead, we are going to use the median. Okay? Then, also, we use, okay, then media, okay, if dili applicable ang mean, that is why we are going to apply the median, no? So pag rank gani, median ang gamiton. Okay, nalang ko i-comment about na may uban sa inyo nagamit o may nagamit o say tawagan na Likert scale, no? Actually, dapat unta class ang most appropriate ana kung kami mo kuan statistician, ang most appropriate ana is ang median. Kaso, kung mugamit ka og median, ang interpretation dayon is medyo lisod. Medyo lisod ba? So, that is why kuan, we tend to apply na lang the mean. No? Ang mean. Anyway, 1, 2, 3, 4 naman ang kuan. 1, 2, 3, 4 naman ang or 1, 2, 3, 4, 5 naman ang Likert scale. So, almost dili na kayo significant ang difference sa kuan kanang sa imong median ug ang imong mean. So, kato, para mas ayon i-interpret, mas ayon ang kuan. So, basa matan-aw mo sa mga sample research, no? Instead of median gigamit, mean na lang ilang gigamit sa katong mga Likert scale. No? Then if kuan, categorical ang imong data, so that is where we use mode. Pero kung how you present it through frequency distributions, no? So anara, present it through frequency distributions, unsa gipangita ang mode, katurang pinakadaghan. So mo na din ito imong i-discuss sa imong kuan, mo na din ito imong i-discuss sa imong imong results, no? So ang most frequent observation kani. So ana. So mo na siya, no? So that is when we use these three and when we not use these three. Then napunta gitawag nga measures of spread. So, unsa ning spread or variability. So we just simply, if pagkuha tag measures of variability, we are measuring how spread the data are unsa kakatag. Ano? Kung tanawon nimo ng red, ang iyang kuana na iyang variability ana is less. Pero kung tanawon nimo ng blue, ang iyang variability ana is very wide, no? So that is the purpose, no? So dili lang ang center imong tan-awon kung mag-analyze og data, dili lang ang center imong tan-awon. But also, kung tan-awon sa nimo unsay iyang spread, no? Unsa nga imong spread? Ana lagi ka, hala dagko ay silang scores, pero ang spread day kay wide. So meaning nay bagsak, di ba? Compared to ang ilalaging scores is ang ilang scores is medyo kanang okay lang dayon ang spread is gamay ra ang spread, so meaning good ang imong result, though wala kay kanang low ang average, pero at least kung namo gani bagsak gamay ra compared aning blue. Do dako ang score pero kung tanaw nimo murag dagan pud bagsak, di ba? Anyway, so that's how you interpret it. That is in education, no? Pero you can also in business, pwede pa nimo na siya ma-interpret, or in other fields, no? Pwede like for interpretation na. Okay? These are the 4 measures of variability. So I will not discuss anymore kanang how to compute, no, pero I am going to discuss when are we going to use them. So I guess that is the very parang most of us miss, no? Kabaluta mo compute but we don't know when to use them, no? So when do we use these 4? Okay, the applications aning 4. Okay, we use range kung in an instant we are going to describe the spread of the data. Okay, ang imong tanawon sa range is highest minus lowest raman. Highest score minus lowest score. Pero weak siya nga measure of spread because dili niya tan-awon ang differences sa individual data set. Ang highest ug lowest lang yung tadawon. So, kwan siya, pangit siya nga measure. Parang kwan lang ka, kanang by chance, kung tanawon lang nimo, ala, katag lagi kay ang data, no? Without computing it, kung gusto ka nimo bawaan how spread the data in an instant, no? Without using Excel or any computations, range itong gamiton. Okay. Next is kaning mean absolute deviation o kaning variance and standard deviation, no? Magamit na to ni sila kung ang iyang partner sa measure of central tendency yung gamit is ang mean. Ang difference is that ang mean absolute deviation is used kung skewed ang imong distribution. Also ginagamit po nila sa mga forecasting plus ang kaning absolute mean absolute deviation kanang forecasting errors MAD gapoy ginagamit na. Pero kung for inference, statistical inference kanang mag assume og normal distributions, variance and standard deviation ang atong kuan, no? Okay. Nganong pinaka importante kay mabawaan ngano ang kuan kaning kailangan yun we have to be very strict kaning normally distributed or daily normally distributed ang distributions. Ang mostly distributions mong god is normal. Even test scores ninyo, normal na siya. So that is why pag maingon ta og mga magamit ta og mean and standard deviation or mga statistical test na mag-involve og mean and standard deviation, mga powerful tool na sila because we see them oftenly. Pero there are some cases like income, for example, no? There are some cases nga ang distribution is not normal. Like income, for example. Di ba, kung tanawon nimong income, mas dagan low earners compared to average. Kanya mas dagan pod average compared sa katong mga extremely rich, di ba? So kana nga kind of distribution, it's skewed. In fact, that is positively skewed, no? Mas dagan ang naa sa left side kaysa right side. So in that cases, we cannot employ kanang mga tools na mag-assume og normal distributions. So in that case, like median for example, ang atong gamiton na is kanang income for example, atong gamiton na measure of central tendency is median. Dayon ang measure of variability, we use the quartile deviation and interquartile range. Okay, so the last one is quartile deviation and interquartile range. Okay, so kanino gamiton nato ni siya if median ang imong measures of central tendency. Another use aning quartile deviation and interquartile range, there's a formula for it, no? I-discover na lang ninyo ni sa inyong statistics na subject if you have. There's a research subject na kung na may research na subject, pwede ninyo tanawon dito. Quartile deviation and interquartile range is also used to locate if there are some outliers or not. So, unsa din ang outliers? Sobraan kadako nga observation or sobraan kagamay nga observation. Murag siya'y nalahi sa grupo. Mo na outlier, no? Murag sa tanan grupo siya'y nalahi. Diba? Murag sa inyo bitaw, kumbaga kung sa tao pa mga loner nga data set, wala nag-appeal sa grupo. So, mo na gitawag nato sa statistics mga outlier. So, to locate or to determine na nay outlier ang imong data or wala, ginagamit nato ang quartile deviation and interquartile range. No? So, mo na yung mga gamit sa kaniyang mga measures. Okay. Next is the measures of position. So, naalan tayo duha ka measures of position. So naatay gitawag nga percentile rank and z-scores. Ang percentile rank is ang imong location, okay, both are location, no? Pero ang interpretation differs. So, pag mayroon ng percentile rank, let's say 50, let's say nag-take ka o not exam, ibutang rin nito yung percentile rank is 65th percentile. 65th percentile, dili pasabot ka 65 ang imong rate. Ang pasabotan na 65% sa takers na imong na-absent. No? So, ang imong score is above 65% of those who take the NAT exam. No? So, that is the use of percentile rank. No? Ginagamit kayo na sa kanang mga no? Kanang mga entrance exams, especially gamit kina sa mga kanang bitaw magsala bitaw sa eskwelahan. Like I don't know with the USTP, no, kay katong nag-take ko diya kay morag ang ilang dawaton is 80th percentile sa takers. So 80th percentile sa takers katong 8, so meaning ang imong score dapat mo beyond 80th percentile. So ang imong ranking is nasa 80 to 100. So kung dili ka kabot ana nga ranking, dili ka makasulod sa program sa masters. Pero kung makasulod ka, so good kayo ka, no? Pwede ka maka-masters diya sa USTP. So that's one of the application sa percentile rank mo. Kaning Z-scores, location gyapon ni. Ang kuani mo ani is gina-determine pila ka standard deviations ka gikan sa mean. So ang interpretation ani, diya na din magawas ang interpretation nga ikaw average ka nga tao. Ikaw ikaw is above average or below average. So diya na din manggawas ang mga mga interpretations like that. Or ikaw belong ka sa genius na level, no? Or ikaw based sa imong scores dito ka sa the other extreme nga level, no? So diya ka ng mga interpretations, no, kanang mga average, above average, diya nagikan sa z-scores, no? Okay, so those are the applications of the different measures of central tendency, different descriptive statistics, no? So before I will proceed to the hypothesis testing, do you have any questions? Any questions, especially sa inyong pag-conduct sa study? Kaning measures of position dili kay ni ginagamit sa research class, no? Pero kung magparang ka, let's say magparang ka o in a academically or magparang ka for sa trabaho kanang promotion sa trabaho, no? So dili ginagamit ang kuan. Wait lang class ha. Hello. Ana ganyan ita? Ayun, ang gamit sa measure of position kanang pagparangka kanang academically or kanang sa magpa-promote ka, ang promotion kinahanglan ay ranking. So based sa performance, I don't know kung applicable ba ni sa uban mga agency, but in some agency they really do apply no kaning mga measures of position. Based sa imong ranking, based sa imong percentile rank or based sa imong Z scores, you will be given the promotion. No? So that's the purpose of the measures of position. Atong variability, measures of central tendency, atong mga frequency distribution, yun, common kito sa mga research. No? Common po kito kanang mga analytics, kanang diya sa gina-present sa kuan, sa table, sa kanang media, no? Gamit, dadto na siya gamit, no? Mga, atong nga mga other measures sa descriptive statistics. Okay. Questions from the group?
None so far, sir.
None. So at least na damlagan na mo gamay, no? So katong wala pa ka-decide sa ilang measures of descriptive statistics nga gamiton sa ilang investigation, so at least madamlagan na mo gamay. Anyway, so I will proceed to hypothesis testing. Gamay lang ko ani class, no? So again, dili na kay ko mo touch o mga computations, no? Ang ako lang ani is when to use them. Okay? And I guess mo na pinaka-importante sa tanan. So what is hypothesis testing? So this is a process of making an inference or generalization about the population. So, di ba, sa inyong study na kay population, so kinsa tayo yung population, no? Dayon nagkuha mo portion tong population, dadto dayon ninyo nagkuan mo, nag-gather mo og data, nag-gather mo og mga descriptive inyong i-summarize na may mga descriptive statistics, ano? So na may ipang-computer nga descriptive statistics. Then from there, you try to make an inference, no? So you try to make an inference about imo i-process, okay, some analysis. Then you try to make a generalization of your population. So gikan sa sample, tinuod kaniya kung nag-gather nga data, tinuod ba kani nga observation kung whole population akong tan-awon. So diyan na din mo gawa si hypothesis testing, no? So ni-test mo na din ni mo ang test. So na may tawag ni nato nga nakikitawag nato nga ala dili lagi sila pareha. Pero kung imong i-test, no, statistically equal ready ay ito, no? So ana. So that is the purpose of hypothesis testing. Though na-difference sa sample or na-relationship sa sample, pero kung tanaw nimo ang in general sense as a whole, different ba gyud or na ba gyud relationship ba gyud, no? So that is the purpose of hypothesis testing. So mayroong taog hypothesis test, it's a prediction made by a researcher regarding the possible outcome, no? So it's simply a guess, okay? So comparison between null and so in hypothesis testing, the first step is kuan man, di ba, you define your null and alternative hypothesis. Sa paper kay kuan man na, sa paper kay null hypothesis ra man ilay ipasulat. Dili na kailangan ng alternative kay kung ma-reject ang null, so opposite sa null na diretso ang imong imong i-state, di ba? Inana man na siya. So, pag may taong null hypothesis, it's a statement about the population parameter that is free from bias. No? Free from bias. Unsa din, anong free from bias? So, meaning they are evenly equal, no? Evenly equal if you are going to uh, test the kung test for the difference relationship kung walay bias meaning walay nag-exist na relationship between the two, no? So that is the statement free from bias, no? Kung sa crime pa na, kung sa crime pa na, no? So ang imong null hypothesis sa crime is that ang usa ka tao is innocent. Wala pay so walay bias meaning wala say sala na kung i-company mo na sa crime. Okay. So ana ba na sa crime, di ba? The person is guilty unless it is ano na remains innocent unless proven guilty, no? So a person remains innocent unless the person remains is proven guilty. Nana. So that is called yapon sa null hypothesis. It's a statement free from bias. So walay kalainan kung you are going to test for difference, walay relationship if you are going to test for relationship. Then the opposite of the null hypothesis is the alternative. Kung false ang null, mao din to siya ang imong alternative. So kung tanawon nimo din so null hypothesis equal. So sa PICAS, so naay growth, no? There is difference. So yun. So it is a statement when the null hypothesis is false. Then also, okay. So there are some errors in the null hypothesis, no? So okay, so when we reject the null hypothesis when the statement is false, mo na siya that is a true statement man na siya, no? That is a correct decision. And we do not reject if it is true. So mo na siya ang kwan. That is also a correct decision. Okay. So when do not correct decisions apply? So kung mo reject ang null hypothesis, pero ang null hypothesis is true, so that is what we call the type 1 error. So kung sa analysis pa, kuan, yun. So those are the examples, no? Pag type 1 error, you're pregnant. So false positive. So dapat unta walay kalainan, no? Walay difference, piningon ka nga nay difference. So that is not incorrect. Incorrect decision. Dayon, type 2 error is kani gitawag nato nga false negative. So you did not reject the null hypothesis. You did not reject the null hypothesis when in fact it is false. So anyway, there's an analogy in the picture there, no? Okay, class. Okay. In hypothesis testing, no, ang kuha na to sa common yun nga statistics. Ang atong ginatanaw is ang alpha, no? Ang alpha. Dili ang beta. Sa advanced na ang beta. Ang alpha gid ang pinaka kuan. So, ang analogy ana is we will try not to give a verdict on an innocent people. Ina ang analogy niya ba? So dili ta mo kuan atong iwasan nga kuan ta og guilty to an innocent. So that is why sa tanan research dili ang beta ang ginatanaw, ang alpha ang ginatanaw. So ang ginakuan nato tawagan na. So we try to avoid reject the null hypothesis when in fact it is true, no? So that is why common gid sa kanang hypothesis test na alpha ang ginagamit. May significant difference class. Anyway, sa mga kuha lang, no? Proceed na, no? Okay, so here are some, so step 2 kay decide ka sa the type of ano, decide for your level of significance alpha. So mo tong type 1 error. Next step is you decide the statistical test nga imong gamiton. So for significant difference mo ning mga test, no? So mo ning mga test nga imong tanawon. Okay. Kindly take note of the nature of observation, no? Dayon, we compare it to the appropriate statistical tests that we are going to use. Okay, commonly sa research ang ginagamit is kaning t-test o one-way ANOVA, no? Kaning t-test o t-test and one-way ANOVA, no? Mo ni kasagara ginagamit kay kasagara nato data wala man ta kabalo sa population variance, dili man na siya given. And wala pud tay kuan ana kanang wala pud tay measure para mo siguro mo estimate ta, we can estimate, pero practically dili gid na sila given. So that is why ang ginagamit sa research, no, or ginagamit sa mga common investigation aning t-test for dependent samples, paired t-test, and one-way ANOVA. So mo man ang ginagamit for testing for difference. Unsa day kalainan aning independent samples o dependent samples? Independent samples class duha, isa ka observation, duha ka grupo, no? Isa ka observation, duha ka grupo. So example ana, i-compare nako kung i-compare nako inyong performance sa lain nga section, akong gamiton na is t-test for independent samples. Pag may ta og dependent samples, duha ka observation, isa ra ka grupo. Duha ka observation, isa ra ka grupo. Example ana kung akong i-compare inyong pre-test ug post-test. So paired t-test atong gamiton ana. Kung more than 3 samples na or more than 3 groups na or 3 or more groups na, mo nang one-way ANOVA atong gamiton, no? So kanang uban mga theoretical na pero ang mga kaning practical kaning tulo, no, mo na kasagara ginagamit sa research. Okay, nabada ko na yung significant relationship. Naabag yung kaha. Anyway, so here are some tests, no, we use for statistical independence. Independence meaning one, not related. So test the same gyapon na siya for test for relationship, no? Kung independent siya, may relationship. Kung independent, walay relationship. So kung mag-deal ta og numerical data with normal distributions, Pearson correlation tong gamiton. Pero kung ang assumption sa Pearson correlation dili ma met, no? So mo nang Spearman rank and Kendall's tau atong gamiton, no? Then if we employ kaning mga categorical type of data, okay, categorical type of data, mo nang gitawag mo na ginagamit nato nga ang chi-squared test for that, no? So yun. Then another statistical measures, okay, kung if we are going to test is kaning observation, parehas ba ni sa katong imong gi-hypothesize sa distribution, no? Or the distribution in theory. So ang gamiton nato ana is chi-squared goodness of fit test. Then if you wish to predict something or na kay predictors, no? Imong kwaon nimo ang strength sa effect sa predictors, or kung mag forecast ka, we use linear regression for that one, no? So those are the different statistical measures, no? For hypothesis testing. Okay. So after you decide for the statistical tool, mao man na i-compute din nimo ang mga statistical mga test statistic. After you compute for the test statistic, dayon ikuha nimo, you create a decision whether if it's reject or fail to reject the null hypothesis. Dayon pinaka last step dayon is you conclude.